Hello students, this is Mr. Ezra. Today we're going to talk about solving quadratic equations by completing the square. And I kind of want to, before we begin, just mention that as we learn new ways to solve quadratic equations, it doesn't mean that the old ones don't work. There are cases where factoring is perhaps easier than completing the square, and there are times where completing the square is a method that you can use when factoring does not work. So we're adding a new tool to the toolbox, and hopefully it'll help us get out of some situations in the near future. So today, solving quadratic equations by completing the square. So the steps are listed here. Solving quadratic equations by completing the square. You can think about it as 6 steps. First, we're going to put it in a form where the constant is on the right side and all the x parts are on the left. So we're going to add or subtract the constant to get it across the equal sign if it's not already over there. We're then going to add b over 2 squared to both sides of the equation. And you'll see that work done in a minute. Once we do that, we'll factor, take the square root of both sides, and then solve for x. All right. Checking your answers is always essential. I might not do that to keep this video kind of short, but anytime you want to make sure you got the right answer when you're solving an equation, you plug what you got into your starting equation and see if it's true. And if it's true, you know you got the right answer. All right, so let's go ahead and look at question number 1. So remember, the first step is to move the constant to the other side. Now, I've been doing this for many years, and I always like to leave myself a little space right here. In fact, if you want to put yourself a little box right there, leave yourself a little bit of space and put yourself a little box there. That'll be nice. So we are going to subtract 54 to get it across the equal sign. So I've got this empty space here. I'm going to subtract 54. Now minus 54 and negative 54 is on the right side. And I'm also going to put a box on the right side. So the reason I'm doing this is the second step is to add b over 2 squared to both sides of the equation. Well, remember, b is the middle term if it's an ax squared plus bx plus c order. In this case, it is negative 10, right? So we need to find negative 10 over 2 squared. And what I like to do is kind of off to the side somewhere. I'll say, well, what is negative 10b over 2 squared? Well, negative 10 divided by 2 is negative 5, right? And negative 5 squared is positive 25. When you square a negative like this, your answer should always be positive because a negative times a negative is a positive. So I'm going to add 25 to the left side of the equal sign right here. And I'm going to add 25 to the right side of the equal sign right here. Now, as we do this, we're kind of playing a little mathematical trick here, a little algebraic trick. Before, in the starting equation, we had something that was non-factorable. But by using this method of completing the square, we're adding something at the end on the left here of x squared minus 10x so that it becomes something that is factorable. And in fact, the factorable thing is called a perfect square binomial. Okay, so if you think about it this way, whatever you got for b over 2, which in this case is negative 10 over 2. Well, negative 10 over 2 is negative 5. That's what's going to go in the parentheses. Essentially, it's half of negative 10, right? And then negative 5 squared is 25. So you can think about it that way. Half of negative 10 is negative 5. Negative 5 squared is 25. This is simply b over 2, right? Now, on the right side of the equal sign, negative 54 plus 25 is negative 29. All right, now that we've done this, we can move on to, we've factored. This trinomial is a special way to factor called the perfect square binomial, x minus 5 squared. If you were to FOIL this out, you would have x minus 5 times x minus 5, and you can try that and see, and it promise it multiplies to give you x squared minus 10x plus 25. All right, so the next thing we're going to do is we're going to take the square root of both sides. I'm just going to kind of show that I'm doing that here. Square root on the left, square root on the right. Now, on the left side, when I take the square root of something that is squared, I just get that thing. They kind of undo each other. So I've got x minus 5 on the left. On the right side, remember, this square root could be positive or negative. So I'm going to put positive or negative square root of negative 29. Now, I've got a few things to think about. Number one, I'm going to solve for x. I've got to get rid of this minus 5 on the left, but also I have something that I can simplify on the right, right? So the square root of a negative, that negative comes out as the letter I, right? Comes out as the letter I. I is the square root of negative 1. 29 is not a perfect square. And if you think of all the perfect squares that are less than 29, like 4 and 9 and 16, none of them divide into 29. So we can't reduce that one any more than it is already reduced. So as I come to my next step, I'm going to add the 5 to the right side of the equal sign because to go across an equal sign, we use an opposite operation. I need everything on the right to solve for x. I'm going to add 5 over, and I'm just going to add it to the front here. Right here at plus 5 is going to be at the front. And then I'll add or subtract I times, remember we popped out the I, so it's not under the radical anymore, the square root of 29. Now, these are the two answers here, right? We have the positive answer, which is 5 plus I root 29, and we have the other answer, 5 minus I times the square root of 29. And this complex answer, I'm just going to circle right here, and this is going to represent both of those solutions. All right, let's look at number 2. Remember, you can pause the video anytime if you want to try one. You've maybe seen a few. Pause it, try the next one, see if you can get it right. All right, number 2. So we've got x squared minus 18x on the left. That's the first step of moving the constant to the other side by subtracting 85 to the right. Get it across the equal sign by doing an opposite operation of addition. You want to leave yourself a space or a box here, and that's where you put the b over 2 squared. We're going to force this thing to become a perfect square trinomial that we can factor. Okay, so b, let's come over here to the left. What goes in the box is b, which is negative 18, over 2 squared. Well, that's negative 9 squared. Negative 9 times negative 9 is positive 81. So what we're going to add essentially is 81 to both the left and the right side of this equation. Now, we've kind of tricked this out, right? By adding 81 on both the left and the right side, now we have a perfect squared, something that will factor to give us a perfect square binomial. It's good. The b over 2, or negative 18 over 2, which is minus 9, is going to go inside the parentheses with x minus 9, and it's going to be squared, right? Because x minus 9 times x minus 9 is actually x squared minus 18x plus 81. We've tricked this by completing the square, by making it something that we could factor. Negative 85 plus 81 is negative 4. Okay. Now we're going to take the square root of both sides. On the left, it's going to basically cancel out with the squared part. So x minus 9 squared is going to cancel the square root and the squared part, leaving us with x minus 9. On the right side, we've got positive or negative square root of negative 4. Please remember that negatives come out as the letter I. If they're under a square root, we're going to take that out as an imaginary number. The square root of 4 is a perfect square. It's 2. All right. So on the next step, so we're working this out, we do have to take the 9 across the equal sign. We're going to use addition to do that since it's negative, to give us a positive 9 on the right side of the equal sign. But we still have this plus or minus I times 2, which we always write as 2I. And again, once you get here, you should certainly check your answer by plugging it in for x here and working it out. You should get 0. I do believe that is the correct answer. All right, let's look at another example. We might try to move a little bit quicker here. So We have x squared plus 20x minus 73 equals 0. We'll keep the x squared plus 20x on the left. We'll add 73 since it's negative to the right, leaving ourselves a little space here, right? Space here and here. And what goes in that space? Well, what goes in that space is b over 2 squared. So 20 over 2 squared, which 20 divided by 2 is 10. 10 over 2, I'm sorry, 20 over 2 is 10. 10 squared is 100. So that's what we're going to add on both sides, 100. On the left, we now have something that is factorable. And the easiest thing I think to do is just that b over 2 that you got here. 20 over 2 is 10. That's what's going to go inside x plus 10. I like to think of it as just half of 20. Half of 20 is 10 squared. 73 plus 100 is 173. Now we take the square root of both sides. On the left, we're just going to be left with x plus 10. On the right, it's positive negative square root of 173. So what's going on here? Well, 173 is not a perfect square. And you can think of all the perfect squares that are less than 173 and try to divide them into 173. None of them divide evenly, so we can't reduce it. So we're essentially kind of stuck with this radical the way that it is. The only thing we can do is to subtract 10 to the right to get x by itself. So when you subtract it across, remember you want that negative 10 to go first, and then the plus or minus root 173. There are two solutions here. Oops. There are two solutions here. There's negative 10 plus root 173 and negative 10 minus root 173. Number 4. X squared plus 6x on the left. We're going to subtract 90 on the right, but when we subtract this time, there's already something over there, isn't there? So I'm subtracting 90 here and it cancels out, and I'm leaving a space because I know what's coming. I know I'm going to complete the square. But I do have to subtract 90 from 8, not from 0 this time. So 8 minus 90 is negative 82. All right. I still have my spaces in here where I'm going to add b over 2 squared. Well, let's find out what b over 2 squared is over here. That's going to be 6 over 2 squared. Well, 6 divided by 2 is 3. 3 squared is 9. So what am I going to add on both sides? I'm going to add 9. On the left, I have something that is now factorable. Half of 6, or b over 2, is positive 3 squared. And negative 82 plus 9 is negative 7, 3. We're going to take the square root of both sides. Remember, on the right side, it's always positive or negative. You always have two roots when there's a quadratic. And so x plus 3 equals positive or negative square root of negative 73. Here, the negative comes out as the letter I. But 73 is not a perfect square, and no perfect squares divide into it, so it's going to stay under the radical. We will subtract 3 across the equal sign to get x by itself, plus or minus I times the square root of 73. So you can probably see by now that none of these that we've looked at so far would have been factorable. So we could have tried to factor, and it just wouldn't have worked. All the different methods of factoring that we've talked about, none of them would work, and we would be stuck. It would be unfactorable, or it would be prime. Well, we can still solve when we have these complex solutions, or when we have these solutions with irrational parts. We just have to use a different method, and completing the square is one of those methods. Let's speed up through a few more examples, and hopefully you will be ready to tackle some of these on your own. So x squared minus 10x plus a space equals, remember, I'm adding 56 to 6, which gives me, let's see, 62. And I'm going to leave myself a space here. What goes in the space, excuse me, what goes in the space is b over 2 squared, which is negative 10 over 2 squared, which is negative 5 squared, which is positive 25. It's going to go in those spaces. Plus 25 here, plus 25 here. Now I can take x negative 10 over 2 is minus 5 squared on the left. That factors this. 62 plus 25 is 87. Now I take the square root on both sides, positive or negative on the right, to get x minus 5 equals positive or negative 87. You always want to try to reduce a radical if you can. I've seen a lot of examples today where they don't reduce, but I don't want you to get a false sense of you don't have to reduce this guy. If this were a perfect square, or if a perfect square divided into it, and you don't reduce it, then you could lose some points. So you want to make sure that you check perfect squares less than 87 and make sure none of them divide evenly into 87. In this case, you try that, it doesn't work. So I'm going to add 5 to the right to get 5 plus or minus the square root of 87, and that is my final answer. Number 6, let's see, x squared minus 14x on the left, give myself room with the space, subtract, since it's positive, 75 to the right to give me negative 83 equals negative 83. Subtracting 75, what goes in the box? Well, the box is going to be equal to b, which is negative 14 over 2 squared. That's negative 7 squared, which is positive 49. That's what we're going to add on both sides. And by adding 49 on both sides, we now have a perfect square binomial on the left of x minus, remember it's b over 2, negative 14 over 2, x minus 7 squared. Negative 83 plus 49 is negative 34. Take the square root of both sides, making sure that outside the radical you get a positive or negative on the right side of your equation, giving us x minus 7 equals positive or negative the square root of negative 34. Can we reduce the square root of negative 34? Well, the negative is going to come out as an I. So square root of negative 1 is an imaginary number. 34 does not have a perfect square that divides into it that I can think of. 4 doesn't go into it, 9 doesn't go into it, 16 doesn't go into it, 25 doesn't go into it. Nothing smaller than 34 does. So again, we have a situation where it's going to stay a radical. But that last step is to solve for x, which means we're going to add 7 across, put it first, plus or minus. I goes in front of the radical, 34. That is our final answer. So in your notes, I'm going to skip this last challenge. You can try it on your own if you want to. We'll look at it a little bit later, but let's just do one more. If you still need another example, if not, you could probably skip ahead a little bit or try it on your own and then see if you got it right. But we'll do it quickly. Subtract 36 to the right. What are we going to add on both sides? Well, b, negative 8 over 2 squared. That's negative 4 squared, which is, the box equals box here, negative 4 squared is positive 16. So we'll add 16 here, we'll add 16 here. On the left, I'm going to have x, negative 8 over 2 is minus 4 squared. Negative 36 plus 16 is negative 20. Finally, take the square root of both sides, positive or negative square root on the right, and I finally have something I can deal with here. So I'll go ahead and do this x minus 4 because the square root and the square cancel out on the left. Positive or negative square root of negative 20. All right, so the negative under the radical comes out as an imaginary number. 20 can be expressed as 4 times 5. 4 is a perfect square. You want to think of the biggest perfect square that goes into 20, and 4 is what it is. And the square root of 4 is 2. So it's going to come out here in front of the I, 2i root 5. Okay, so when I come to my next step to solve for x, I'm going to add the 4 to the right. I always put it first. X equals positive 4 plus 4, plus or minus. And remember, this simplified to the square root of 4, which is 2. Negative under the radical comes out as an I, so 2i. And what's left behind is that square root of 5. So that is several examples for completing the square. Want to mention really quickly before I end the video that we have been looking at some fairly simple types of completing the square situations. The next video we'll look at some more complicated ones. Things that you'll have noticed perhaps are that we always had a leading coefficient of 1. Something else that you may have noticed is that we always had an even b. You know, this method works well when b is even, because if it's not even, you're going to end up with fractions and you're going to have to deal with some fraction work, which is not a big deal, but it's up for some students that, they don't like to do that. So with that said, we'll look at these more in class. Go ahead and check out the next video where we look at some more complicated types of situations.